In the Viking Age, a warrior's status lived in the steel at his hip, and among thousands of surviving blades, a small, puzzling group stands apart. Swords inlaid with the name Ulfberht plus. About 170 have been recorded so far, mostly from burials and river finds across northern Europe, and they date broadly to the 9th to 11th centuries. The inscription itself is probably Frankish rather than Norse, which fits a picture of production in the Carolingian Rhineland sphere and distribution north through trade, gift, loot, and ransom. What made a subset of these blades extraordinary wasn't myth or magic, but metal. Most early medieval European swords were built from bloomery iron steel, heterogeneous metal made in low-temperature furnaces that left slag inclusions and variable carbon. Smiths managed those flaws with pattern welding and selective steel edges, but the structure remained composite. Metallographic sections from several Ulfberht-marked blades show something different. A near-homogeneous, very low slag, high carbon steel consistent with crucible steel. In crucible production, iron and carbon are sealed in a ceramic pot and heated to full liquid or near liquid temperatures. Slag separates out and carbon content equilibrates, producing a fine, uniform matrix that can harden deeply and keep a sharp edge. Microstructures reported from Wallace Collection studies include hyper-eutectoid steel with spheroidized cementite, high microhardness values from edge to core, and inclusion chemistries unlike ordinary bloomery stock, signals that at least some Ulfberhts were forged from crucible steel billets. Crucially, not all Ulfberht plus blades are equal. The brand seems to have been imitated widely. Other swords with similar legends show typical pattern-welded construction, more slag, and uneven carbon, serviceable weapons, but metallurgically conventional. That spread of quality across blades with related inscriptions is itself a clue. Ulfberht functioned less like a single Smith S signature, and more like a workshop mark or trusted name others tried to copy. Where did the crucible steel come from? The likeliest answer lies along the same eastern corridors that ferried dirhams into the Baltic economy. During the 9th–10th centuries, river networks via Ladoga Novgorod to the Volga and Dnieper connected Scandinavian and North European markets to the Abbasid and Samanid mints and to Central Asian metallurgical hubs. In those regions, true crucible steel, wootz, was made and traded as ingots. Laboratory evidence can't yet fingerprint iron as neatly as silver, but the combination of microstructures consistent with crucible steel and the archaeological record of Eastern trade makes an imported ingot supply chain plausible. The timeline also aligns. Authentic, high-quality Ulfberhts cluster in the centuries when the Volga route and steppe brokerage flourished, then fade as those networks shift in the 11th century. Inside the lab, the difference between bloomery and crucible blades is read in several ways. Metallography under reflected light reveals the distribution and form of cementite and pearlite. Hyper-eutectoid crucible steel shows fine, evenly distributed carbides rather than the banded slag-drag structures typical of bloomery composites. SEM-EDS and inclusion chemistry help separate low-slag crucible matrices from bloomery steels with entrapped furnace products. Microhardness traverses map heat treatment and edge-to-core uniformity. Some Ulfberht edges test markedly harder than their cores, yet remain far more consistent than ordinary pattern-welded foils. Those results carry performance implications. Deeper hardenability means edges that can hold an acute angle without crumbling, while uniform cores reduce weak interfaces, provided heat treatment avoids brittleness. Limits matter too. Sample sizes are small. Some blades were rehardened, repaired, or re-edged. Corrosion obscures signals. And crucible steel spans a range of carbon and processing routes. A few scholars argue that all authentic Ulfberhts were European bloomery steels, and crucible identifications reflect misread microstructures or later interventions. Yet multiple independently examined blades now show low slag, high carbon matrices that are difficult to produce by bloomery routes alone. and they sit in a wider archaeological context of Eastern materials moving west. Taken proportionally, the case for imported crucible steel in a subset of Ulfberht swords is strong. What this changes is our image of technological flow. The blades don't prove that Viking-age smiths invented crucible steel. They show that some European craftsmen could recognize superior material, obtain it through long-distance networks, and forge it into weapons that outperformed their peers. In other words, Ulfberhts are not anomalies dropped from the future, but products of a connected medieval world in which expertise and ingots traveled as far and as fast as profits allowed. If you want more lab-driven breakdowns of how archaeology and metallography separate legend from metal, starting with the Ulfberht plus name and the steels behind it, stick with us for the next metallurgy deep dive and tell us which blade tradition we should put under the microscope next.